This first guy is just looking for the Cray asymptote. I believe it was page 8 on your notes in your packet. Maybe it was 7.
No.
Yeah, 7. Because what's different about this guy? Why does this guy look different? There's a ton of junk up here, but what's at the bottom? Just one little term. So what can you do? Yeah, divide each piece just by this. So you're going to divide every single piece just by 2x to the third and see what you get. You remember doing that?
Mm-hmm.
Yeah? Okay. 3x to the fourth, 2x to the third, plus negative 12x to the third over 2x to the third. Can I knock any of these out? Are there any of these that are not going to matter when I go to divide? Definitely the negative 9. Why can I knock this guy out? It's what? You'll get a remainder, right? We didn't care about remainders for the asymptotes, so we just ignore them. Is there any other one that would be a remainder? Let's go through and see what happens. Yeah, if we simplify this, what does the exponent on x become? I have an x to the 7th divided by an x to the 3rd. It would be x to the 4th, right? Because you got 7 x's. Remember, if you had to expand it, you could. 1, 2, 3, 4, 5, 6, 7 over 3. And then you can knock them out and see what you have left over, right? When in doubt, you can go back and you can expand stuff. 5 over 2, we can't really do anything with, so we just leave it. Yeah? What does this guy become when I simplify it? 4x to the 2nd, good. How about this guy? Negative 3 over 2, x, and then how about this guy? Negative 6, both x to the 3rd knock out. So then what about this guy? This is going to be part of my remainder also, right? Because I would end up with x's in my denominator. We don't care about that.
So the remainder would be whenever there's...
Oh my God.
Yes, whenever there's leftover x's in the denominator. So this, y equals this, is the equation of that Cray, I call them Cray asymptotes. You're going to see it as other asymptotes, but that's a crazy asymptote. Do you know what an x to the 4th power looks like? What does that graph look like?
It probably is down 6.
It's like... Oh, wait, no.
Yeah. Remember, this exponent tells you what? How many what? How many what? How many zeros? Yeah, how many x-intercepts there are. So if you're ever not sure, you can just say 1, 2, 3, 4. That hits 4 times. But in this case, that first term is negative. So instead of looking like a W, it's going to look like an M. I'm going to make a very, very specific blanket statement to you. Ready? If you get a problem that has a crazy asymptote like this, any part of graphing it is going to be bonus. Okay? I don't expect you to know exactly what the graph of this looks like. Could you substitute x values in and get y values out? Absolutely. Okay? But if you get a problem that's like this, any part of graphing it is going to be bonus. And you will see an example. I've got 5 nice problems, kind of like every scenario that you're going to see. Okay? Cool? Smile or not? Okay. Can we look at the next part? Let's start one of these problems fresh. What can you start with? What do you got to do first? Say it one more time. Yes, x squared minus 9 is a conjugate, so what does it turn into? X minus 3, x plus 3. I'm going to show you something. Not sure if you recognized it. What number goes on the top? Why is it negative 2? You see this? I'm very specific when I pick these problems for you, right? I'd rather you goof it up in a warm-up and we get to talk about it than on test or quiz, right? Those are test-taking skills of just being careful and slowing down. Here we go.
Here's a student support interruption.
But it's a lot of stuff, right? Okay, so we've got its factors. We got that negative, right, that we're being careful of. Tell me what information can you pull out of this now? Domain x is not equal to, very good. What did you say? 3 and negative 3. Which one of these is giving me negative 3? The x plus 3. Good, just checking. Okay. I already told you in this case that there's no holes. Hopefully you saw that. What causes holes? When things cancel out. Very good. If there's no holes, how many vertical asymptotes do I have? 2. And you're going to write these guys nice and separately, right? That is the equation of a line. That is the equation of a line. Right? So we can go ahead and we can get these vertical asymptotes in here. Okay? Are you okay there? Yeah? Talk to me about horizontal asymptotes. We're looking for the highest exponent. In this entire function, what's my highest exponent? X squared. So I'm comparing my x squared. How many x squareds do I have in my numerator? 0, because there's literally none of them, right? How many x squareds are in the bottom? 1. So what is 0 divided by 1? 0. That's allowed, right?
Yeah.
So my horizontal asymptote is? Y equals 0. Very good. That is the equation of this guy. Make sure I can see it. You're always allowed to use a highlighter. I like using highlighters for the asymptotes because it keeps it a little separate, and I've got a ton of them back there. What if it was 5 divided by 0? Then there would be none. If there are none, what do you have to check for? The slant or the other ones, right? But since I have a horizontal asymptote, what can you tell me right away? There are none of these. It's one or the other. One or the other. Yeah?
For the slant, it's like a division problem.
Yep, these are the ones where you do long division. Good. Actually, and just so that you know, if you did long division to start with, you would end up with this. And it would give you this one, but our little trick is just easier. Okay? That's actually how you find this one. All right, talk to me about intercepts.
X should always be 0 for Y.
Potentially, yeah. Oh, the x value would be 0 for y-intercept, yep. And for x-intercept, y is going to be 0. Okay. If there's a horizontal asymptote, though, there's something else you have to check for. What do you have to check for? Does it cross? Remember, horizontal asymptotes are half-hearted, right? Slant asymptotes are never going to get crossed. Vertical asymptotes are never going to get crossed. But horizontal asymptotes can get crossed. So how do I check if it crosses this? Very good. I'm going to take this guy right here and set it equal to whatever my simplified version is. Okay? And you do need to do the simplified version. So if you have holes at knockout, it's going to get goofed up if you don't use the simplified version. So my horizontal asymptote is 0 over 1. And this guy is negative 2 x squared minus 9. What happens when I crisscross applesauce? Negative 2 equals? What does that mean? Doesn't cross.
At this time, all students that eat on B and C lunch, please report to the cafeteria at this time.
So close. Okay.
I repeat, all students that eat on B and C lunch, your lunch is at this time, 15 minutes to report at this time.
Okay, shush. So we love you, Miss Smallwood. Okay. So, it's B and C lunch. We're doing lunch. So, talk to me. Which one of these are you not going to have? Why is there no x-intercept? Yeah. Right? This one is the one that we set our numerator equal to 0, just like we do with our domain with our denominator. But our numerator is just negative 2. Does 0 equal negative 2? That doesn't matter, right? And because that's your asymptote, but it doesn't get crossed, right? So doesn't it make sense that there's none? Do you see that? So there are no x-intercepts, absolutely. Do I have a y-intercept? Where does it fall?
Student interruption to all students that eat on B and C lunch. Please report to your cafeteria at this time for your lunch. You have 15-minute lunch period.
B and C are
I
seven.
repeat that to B and C students.
I apologize, I didn't phrase that. Dr.
I'm sorry, I'm just not getting why there's no x-intercepts.
For x-intercepts, how we solve these is we're plugging in 0 for y, right?
Yeah.
But you would multiply the denominator and it would go away.
Oh.
So we would just get 0 equals -2.
And 2 doesn't equal.
There's no variable up there. There has to be a variable up top. Okay? Great questions. I'm glad you're asking them. How about y-intercept?
Or you can f of x is negative 2 over 9.
It should be positive 2 over 9. Why is it positive 2 over 9? We know that our x value equals, so if you have, so you got a -2 divided by a -9, right? So it should be 2 9. Are we okay with that? How would I graph it? All that matters is it above or below my horizontal asymptote? Because that tells me where my graph is, right? So is 2 9 going to be above or below 0? So that's all we care about, is that it's going to be above, and then it's going to look like a parabola up here because it's that middle section. Does that work? All you're really doing with your points is you're comparing them. Is it going to be above or below, above or below, above or below? Do you have any coordinates on these two sides? So what do you need to do? You need to test out those points. What would be a good point to test out and work out here? Yeah, since my asymptote's at -3, we're just going to hop one over and figure out what f of -4 is. And the other side, yep, we're going to hop over 1 to 4. All right, substitute them in if you haven't done so already. Tell me what you get. Be really careful with parentheses, please. -4 squared is +16 minus 9. So is when I input -4, I output -2/7. So when I input -4, I output -2/7.
Oh yeah, oh yeah.
Does that make sense? Every coordinate, right? So all that tells me, all I need to know is it above or below my asymptote, and then it's got to hug my asymptote. Can you draw in the air what this guy's going to look like for me? Draw it in the air. What's it going to look like? I see one person draw. Yeah, it's just going to hug this asymptote, and then curve and hug this asymptote. You okay? How about this one? It should be the same because only x is getting squared. But it's going to be over here. So it's just hugging the asymptote. Those are like the boundaries. How are we feeling? We're okay? You got any other questions?